In this Fixture Friday, I'm going to show you how we did away with the old approach of holding two parts in a vise and replaced it with our vacuum pallet to get 21 parts per cycle.
I was made for this. I was made for this.
So in other Fixture Friday episodes, I've shown how we create fixtures to leverage the principle of high density work holding using our Pro Pallet system. Now in other sets of videos, I've shown you how to hold parts using our SmartVac system that were typically impossible to hold in a vise. But today, we're gonna combine these two product lines to give us an easy 10x production boost. Let's move over to the machine so I can show you our setup. So what we have here is our standard Pro Pallet base. Now the Pro Pallet system holds 4 different sizes of pallets that we offer, but one of the accessories is our vacuum pallet kit. I also have an introductory video of this product that we'll link to in a card and also in the description below. Now, the first operation is made on this vacuum pallet that you see right here. Now, the vacuum pallet kit is nice because if you're going from palletized fixtures, you don't have to remove the PPS base to bolt down one of our dedicated vacuum chucks from our SmartVac product line. The vacuum pallet simply locks on like other pallets. The one thing you'll need to do is to split the incoming compressed air line to our vacuum power unit and to the hand valve for the PPS base. Now keep in mind the PPS base uses compressed air to unlock pallets. There's no vacuum involved with that. But our vacuum power unit converts compressed air to high vacuum level, so this line goes directly into the vacuum pallet itself. Now that we got that covered, let's take a look at the part and the fixture. So the part we're making is the nameplate that you see in the center of our Pro Pallet system. This part is made from aluminum tooling plate. Now, the most common tooling plate is known as Mike 6, but we use variations called ATP5 or K100S. The reason we use these is because ATP5 and K100S are 5000 series aluminum alloys, whereas Mike 6 is a 7000 series. Now, 7000 series aluminum is much harder and a little bit more brittle than the 5000 series, and these parts are threaded in the bottom. So thread quality is a key consideration. Plus, the 5000 series of aluminum anodizes much more easily and brighter and is often used as a decorative grade of aluminum that you sometimes see around windowsills and lighting fixtures. Now, the great thing about this fixture is that the starting blank size isn't just a little bit bigger than the finished part, it's a lot bigger. In fact, we were able to nest 21 pieces out of this roughly 10-inch by 12-inch and quarter-inch thick material. Now for Op 1, we're gonna hold this workpiece on our standard grid pattern vacuum chuck. And in this first operation, we're going to drill and tap and add these 2 locating holes and do a shallow perimeter around the part and then chamfer it. Then we finish it off with a face mill to bring it to its consistent thickness. Now we have the luxury of adding these 2 locating holes. They're not used in assembly and they're only used to make producing these parts easier for the second operation. And let me show you that right now. Now for Op 2, we've machined a customizable top plate. This top plate acts as a sacrificial surface so that if you're machining below the perimeter of the part, you get a full cleanup. You wouldn't be machining into the grid pattern of the chuck. Remember, you always want to keep that pristine and as original as possible. So we've customized this top plate with 21 part positions, and we've used our 1/16 inch diameter gasket, which is inset from the edge of the finished part by 25 thou. And each position has its own vacuum inlet hole. Now, because this part is on the smaller side, we use our 1/16 diameter gasket to maximize the surface area exposed to the vacuum. Remember, more surface area means higher holding force. Now, you'll also notice these two locating bosses. Now, these bosses will hold each part and give it more lateral stability. Keep in mind that it's actually fairly rare for a part to be lifted off a chuck. What's more common is the cutting forces impart lateral force sideways into the part, and the part can slide off of the gasket, and that's where you can have a point of failure. So because we've added these two bosses, the part is located in X and Y, and the vacuum takes care of the Z holding force. Now in Op 1, you'll notice we didn't machine all the way through, just enough to get a good enough depth so that the tip of the chamfer mill doesn't do any cutting, just the sides, and just enough to create a nice chamfered edge. So when we flip this over, we're flipping over 21 parts nested together in one individual workpiece. So handling time, which isn't usually accounted for when we're doing these time studies, is greatly minimized. And you can see right here that not having to handle 21 individual parts is a huge production boost in itself. So when we flip the workpiece over, all the parts are being located individually using the locating bosses and the bores on the bottom of the part, and our vacuum holds it down. Now from here, we're gonna use our face mill to bring it to a final thickness, and then we're going to use an end mill to rough out the perimeter of the raw material. Now we take these two higher cutting force tool paths first because one individual part just doesn't have a lot of surface area, where an oversized starting stock might cause too much cutting force for the vacuum force to support that one part. So now that we've removed the perimeter, we can profile each of these parts so they're separated from each other. Now, if there's one thing that's inefficient about this setup, it's hand unloading 21 individual parts at the end of the cycle. So to overcome that, we have two identical top plates that we rotate in and out so that one top plate comes off with 21 finished parts, but we immediately grab the other identical top plate with the material pre-positioned on it. Now we put it in place, turn on the vacuum, everything gets sandwiched together, and it's ready to go. Now, while we have the finished top plate outside of the machine, we can unload it and prep the next workpiece. Hey, if you know someone in the machining industry that would benefit from these types of approaches, do them a favor and hit that share button and send them a link. And if you ever think that you could use this information in the future, hit the like button, which will save it for you for future reference in your liked videos folder on YouTube. So until next time, go innovate your production.